right, this is SIG scale, December 4th, 2025. Okay. All right, we've had let's see, it's been a few weeks since we've met, so I'm hoping we have a little bit more data that we can start looking at a trend line. Okay. We'll just grab previous one. All right, so we can do some comparisons with this. All right, let's take a look. Really like this. All right. This node counts. Oh, this was the change that Federico was talking about, I think, that we reintroduced. Back to 40. 50. Hmm. Okay, let's see what else. Node CMI count. All right. What's the unit here? 25. Okay, it's about the same. It's the same. Watch counts. 30 to 80. Okay, does that look right too? Yeah, it's the same. Okay. Weekly patch nodes. Same. Um, Lubo, you're here, right? Okay. Lubo, did what was the one we wanted to look at? I can't remember. Oh, we wanted to look at this one. Okay, this is all right, we didn't get or we don't need to get to this yet. Okay, let me just go back. I think we'll get to yours in just a second. I thought it was in here. Okay, let's look at the memory usage. $135. So it's the same. Min memory usage. Huh. This trend line's kind of weird versus this one. There's like something changed here. I don't know what changed. It seems like, hmm, yeah, I don't know how to describe this. It's just like we don't have the zero values here, so the trend line kind of goes to where the cluster is. It's a cluster of data, which is the same, but we just don't have any zeros. And we also don't have these values, whatever this is. So 67. So for the last 30 days or so, we don't have any of these values in the middle. Okay, I don't know what to think about that. 160. Our trend line stays there. Okay. For API usage. Looks the same. About 62. Yeah, it's the same. It's about the same. Okay. I mean, these look like they're all going to be the same, but it looks like we don't have any, nothing really sticks out to me. Okay. I think then that's good. So I think we've got enough data. So we look like, it looks like to me that there was no major change here in these numbers, nothing significant. So that's good. Okay. So I think we're firmly into 134. So that's good. And it looks like it's, we have enough data to make some judgments. Okay, so let's go to the second one, which was what Lubo we've been wanting to understand now for a little while.
I think last time when we did have a look, it didn't seem to be better, right?
Okay, let's see. So all right, you're gonna have to remind me because I can't remember what is it that we wanted to specifically look at. Was there were we getting
I think
zero values or was it like inconsistent create pod counts? Is that what it was?
for the CPU manager, I think we were looking at the P99, P90, P50.
Okay. Okay, so then we do need to look at this chart. Okay. Well, let me bring the other one back up. So I think let's take a look. So 218. When did you make this change? So it was it November? It looks like the data's
October,
the
November.
same.
Let
November,
me
okay.
let, let me check just to be sure. So it was actually merged on 25th September.
September, okay. Okay. So we would see the data a little bit here and then we'd see it here. Um yeah, it's about this. So it looks the same to me. Let's take a look at 95, 30, 29, 30. Yeah, it looks the same to me. Okay.
Yep, probably no improvement.
Okay, that's fine. Okay. All right, was there, so I think we can, yeah, I think we don't need to carry this anymore. I think this looks good. I think I did want to see because our note about this one, excuse me, I think that, yeah, so this is what we wanted to do. We weren't sure if there were resources in contention. And so, yeah, it was, okay, so here, I think it was had to do with the issue where like we weren't seeing the VMI count reach 100. Like we were, where's that? That's one of the metrics too we wanted to check. So we should see, do we track the count? I don't know if we do. Or maybe that's what we're missing. So get, yeah, okay, it's this one, I think. So create pods count. Yeah, so this one, this is where we saw that very strange regression with the based on resource, what we think based on resources. So yeah, I mean we're seeing 100, so this looks good. I think it's just what it's going to do is it should help us make sure we don't have any strange patterns where we had previously where they'd be less than 100. So everything here is above 100, so it's good. That's what we want to see. Yeah, so like here you can see it, like these numbers. We had like 81. Okay, I think that looks good. All right, is there anything else that we need to review? I thought we had, I thought there were several changes that we had in the past. Let me see. Shrija, I saw you made a few changes for the clock, for our clock test. Did all of those merge and did we, maybe we can look at that data? Shrija, did your changes merge for, I think you had, I think you increased the count, right? To, what was it?
Yeah, so the 8,000, I have increased
1,000.
the count to 8,000, but that is not yet merged.
Okay, so we're at 1,000 right now. Okay. And you were going to what, 8,000 you said?
Yeah, 8,000.
Okay. All right, so we don't have that one merged. Let me, do we have, we don't plot the clock changes, right? And we don't, like, I think the ones we care about are the memory, right? That was the thing like the big value of this. We don't plot them anywhere, right? Not that I recall. Do you know, Shrija, like, are we plotting the, like the memory usage for, from this job?
I don't remember exactly. Let me check.
Let me take a quick look at this. So, Verde API memory usage in megabytes 137. So this is 1,000. API. Memory usage in megabytes. 137. So 1,000. Yeah, I mean, this is pretty good. So we don't memory usage in megabytes and vert controller. Vert controller. Okay, so 60. So 191. Okay, so here we can see it scaling up. Okay, this would be cool to plot. Actually, like to see like what the slope of this line is. So in other words, like how many VMs, like what's you could probably plot a theoretical limit actually, or even not even just theoretical limit. You could even do like a theoretical, um, like how much resources that you should expect to use, um, based on the number of VMIs. Because we got because we can look at these 2 points on the line and we can probably build a slope. So 63 and then 191. So this is 100 to, so we're going from 100 to 1,000. And that's 10x. And then we've gone from about 60 to 190. So we've gone 3x to about 3x. So we're scaling. So Vert API, Vert controller memory usage is scaling or growing 3x while the VMI count is growing 10x. Yeah, that would be interesting exercise actually. I'm not sure how we could do like how we could cross plot this because you have to take data from here and then you'd have to take data from here and then you'd have to plot them in one place. I don't know. What do people think about that as an idea? Does that make sense?
I mean, if we have a raw data, then we can do the plotting on custom basis, right?
Yeah, like I think we have the data. Like I think we could. So I think what we don't have right now. So we have the data in Prow. We need to pull it out into. Well, actually, I'm not sure how we would do this, but we would need to we would need to pull the data points out from two different jobs um, and then calculate a slope. Yeah.
So,
So Vishnu, your hand raised. Go ahead.
yeah, sorry to interrupt. Yeah, I'm just joining this call for the first time. So I had some previous chats with Ali in this call. So I'm trying to present KubeRunner here. So just making sure that we're approaching the end of this meeting. If I can get a 5 minute slot, maybe towards the end. Yeah.
Yeah. Um, yeah. We will go to that. We'll give you 5 minutes here, or just well, actually we should. I think we can wrap up this discussion here in just 1 more minute, and then you
Yeah, yeah,
can
sounds
present.
good. Thank you. Yeah.
Yeah, Ryan. So we plot 1.32 QoQ data, but we don't have 1.34 data yet.
Okay, we do. We do. Okay. I think it would be interesting, Shrisha, if we can do if we
Yeah,
can
I'll share
plot
the
these
link.
two and okay, you have the link in the chat. Let me see.
Yeah, but, I mean, it's very limited, but
So I think, Ryan, we just need to wait for this PR to merge. Once this PR is merged, we'll automatically be able to plot 134. And I think we'll be able to combine these two data together.
Okay. Yeah, that would be cool. I think doing like that would be a really interesting thing to publish is theoretical scale based on, clock. I think that's pretty cool. Okay,
Yeah,
let me make a note of
but I
this.
don't think we are scaling linearly because we scaled from 1,000 to 8,000. I think we scaled to 8,000 in that new job. And the memory consumption is only 3x.
Right. Yeah, what I'm thinking is like it's interesting to see how consumption changes relative to
Yeah.
the number of VMs. I think that would be interesting to plot or even to measure. Like we would want, say it's like whatever that ratio is, we would want to maintain that or decrease it. You know, I think that would be interesting to see.
Yeah.
Okay, let me make a note of that. So plot a clock role playing versus SIG 1K versus real 100 VMI. Control plane. Okay. Yeah, this would be an interesting one, Teresa. Would you be able to create an issue for this? I think that would be a really cool one to start experimenting with. I think
Yeah.
you said you gotta wait for probably 134 to merge and then we can start thinking about this.
Yeah.
Okay. Okay, let's go to the cube burner discussion. Do you need to share your screen, Vishnu?
Yeah,
Or is
I can go ahead with the screen share. Yeah,
okay.
I just want to start with an introduction and then provide some context and get into the presentation if you don't mind. For those of you guys who don't know me, I'm Vishnu. I work for Red Hat. I'm based out of Raleigh. So I'm here to present KubeBurner today. To provide a little bit context, so KubeBurner is a Kubernetes based performance and scale test tooling framework basically. So it works on any K8 engine based platform like OpenShift or anything else on top of it. So I had some conversations with LA on Cube at the KubeCon regarding this. So thought this would be a good opportunity to have this plugged into KubeWord and see how it goes. So that is why here I am today. First of all, thanks for this opportunity, and I'll get started with the short demo. I hope my screen is visible. Um,
Yes, that's it.
So yeah, in KubeBurner, the advantage is KubeBurner will help you orchestrate the workload. All a user has to do is define the list of resources that they want to be applied on top of the cluster in a declarative fashion. Just like we apply manifest on top of a Kubernetes cluster, write up everything in YML, for example, VMs or else pods. We write them as a YML and then do a kubectl apply or else OC apply, whatever it is. So the same thing is done by KubeBurner in a Golang way, wherein it uses client Go library to apply those resources on top of the cluster. So the example that you guys are seeing on the screen is how the KubeBurner configuration file looks like. So it's like a metadata, like an index of the book, which has all the information at one place. And when we look into those things in detail, we will get to know what set of resources that it's trying to apply on the cluster and what kind of operations it's trying to perform on the cluster, considering CRUD operations, and then up to what scale it's trying to push the workload, and finally how it's going to conclude it and capture metrics, and then give us some performance related data to understand how this specific workload has impacted the cluster. So this is the global config wherein we specify if we want garbage collection or not, which is like just a cleanup of all the resources deployed after the workload. And then we specify the list of measurements that we want to capture. The good advantage of this one is it supports Go-based templating. So, you can have things rendered at the runtime as well in this configuration. So here we are primarily for the purpose of this demo, I have just tailored it to VMA latency. So what it does is it looks for the Kubernetes events in the runtime and then captures those events to calculate this latency. It does a diff of statuses from the Kubernetes status JSON spec, and then calculates for those latency numbers. And here we specify where we want our metrics to be indexed, which is a bit of templating done here, and then specify the thresholds. For example, here I want to say that I want VMI running latency and its P99th value to be under 10 seconds. So if it is going above that, it will notify us through an alert. And here we specify configuration for our indexer. It can be either Elasticsearch or else local file system as well. And then here is where we define the list of jobs to be executed as a part of the workload. So here we specify the QPSN burst, which will be the QPSN burst numbers to interact with the Kube API server, while client Go library tries to apply stuff on the cluster. And the type of job here in our case, it's a create job because I want to create a VMs as a part of this demo, and then just end up calculating VMI latency to see how much time did it take for the VM to come up from create to running state. And then a little bit of configuration to kind of verify if the workload has reached to a meaningful end state. So here in this case, I want to see all the VMs that are deployed as a part of this workload to be in the running state, and then conclude that the workload is done, and then start capturing metrics. And here is where we specify the manifest files that need to be deployed as a part of objects list. So as you can see, it's a YML list wherein I specify and a bit of input variables which I want them to be rendered at the runtime. And here is the actual file, which basically defines the virtual machine, and some templated stuff which was being passed as an input from the previous metadata file, and it will get rendered at the runtime. The advantage of that is we can use the single configuration file and have it replicated for deploying multiple instances to scale up the workload. So here, this replica number is going to be different for multiple, configurations that are created in the runtime. So that way, multiple VMs get created, and they end up creating load on the cluster. So now I'm going to show how it's going to be in the action. So 1 second. So for the purpose of this demo, I just have a small kind cluster spinned up. So I did set up everything, ad hocly. So here I'm setting up, these are the function definitions above, which I'm not going to talk about for the sake of time. Here we spin up a small client cluster, set up Prometheus on top of it, and then set up OpenSearch, where I want all the metrics that are captured from Prometheus during the workload time, and then scraped from there and published to OpenSearch, and then rendered on top of Grafana for visualization purposes. So I already have the cluster up and running. 1 second. Oh. So now I'm gonna trigger kubeburner. Oh. So here is how I'll be, executing kubeburner. Kubeburner is a Golang binary. It's platform agnostic. So I just downloaded the binary, and then I'm going to use init subcommand, and I'll specify the config file, which was the metadata file that I was talking about earlier, which has entire definition of my workload, along with its scale and other interesting numbers, and specify a unique UUID, which will be a unique identifier for these run specific results, which will help us to do performance and scale analysis later using that UUID as a unique identifier when looking at the metrics. And this is the metric endpoint file, which will help us to specify where our metrics need to be published at, and enabling debug mode. So it will basically first establish a connection with Prometheus client. If your cluster inbuilt already has, you can just specify the details, or specify an ad hoc Prometheus, which is connected to your cluster. And then create indexers like Prometheus, wherever the metrics need to be going as a target. And then read all the configuration, and try to apply virtual machines on top of the cluster. So now what it actually did was it deployed I think a few virtual machines on top of the cluster, and then it was waiting for them to be ready. Once they were in the running state, it considered that the workload is done, which is what we defined according to config file, and then it captured some runtime metrics which are highlighted here. So it will capture metrics like, how much time did it take for the VMI to go to pending state. It will give percentile statistical numbers and stuff, and then finally capture all the metrics, publish them to Elasticsearch, and then conclude the workload. So while CLI looks a little bit boring, we should be able to see the same stuff in Elasticsearch, which is the local instance. So all the metrics are in JSON format, which is flexible for any visualization to quickly load up and visualize on top of it. And then I can just show you. So as you can see here, there are metrics and their aggregates captured, starting from average all the way to P99. And then we should be able to see some time series metrics as well, which will go in more detail. For the purpose of this demo, I have cut them down. So we captured all critical metrics like VMI, starting from schedule to all the way running phase, and then same for the pods that are involved as a part of the VMI creation, and then ended up capturing all the stats. When we load the data into Grafana, here is how we are currently visualizing for all visualizing these metrics for the purpose of our tests. But these are something that can be worked through based upon end users use case. So this is just an example. So here we can see all the latency numbers for VMIs as well as pods involved in those. So any questions so far?
This is pretty cool. So does can you express like when you create these VMIs, do you create them all at once? Like, do you sort of have one? Like, would you like say like our job does 100 now? Like, how can KubeRunners sort of control the creation? Does it do it in batches? Does it do one at a time? Does it you do all 100? I'm curious like how it does the creation and how configurable it is.
Yeah, good question. So it uses parallelism to create all the objects, and then it plays according to the QPS and burst number specified here. So QPS would say queries per second. Burst is slightly different metric, which basically defines on how much the wait queue length should be when there's a peak situation. I mean, the general QPS and burst metrics which apply to K8s as well. So using this, it will regulate the workload. And when it comes to replicas, we have something called job iterations. Right now here it's not present, but that is what specifies the number of resources to be deployed. If it is specified as 100, it will end up deploying 100 VMs with QPS burst as 2020. I mean, as specified here, we can work through those numbers and then, scale it up to that level. But it should be like it should be negligible and couldn't be, it's not something that is easily noticeable by a human. So it's pretty fast.
Okay, so QPS burst, this is in reference to the controller, like the Kubernetes controller, or is this like the QPS and burst on like the API server? Like which way is it controlling?
The API server to be specific. So all these manifests that are getting applied on top of the cluster, they're nothing but a request to API server, right? So that is what this QPS and burst are regulating. Well, we use client Go in our code base to do that stuff.
Okay.
Sure, and this is the client Go QPS. Basically, it means KubeBurner will be able to make 20 queries per second. So if our job is to create 20 VMIs, then it will do that in 1 second. If it is 100 VMIs, then it will take 4 seconds. Well, 5 seconds, sorry.
Yeah.
Right. Okay. Do you have any other, does Kubernetes do any other types of tests besides, so like the approach of QPS and burst would be like you're creating everything and then watching for the results. Are there ones like I can create all of them and then we can we could delete and recreate them, like kind of like I guess like a steady state test and sort of watch like while we're at a large capacity, how quickly they get recreated.
Yeah, so we have a wide variety of examples on KubeBurner. I mean, people use it for different purposes. So first thing, it's flexible to the user. They can define their own workload. They can specify what runtime measurements that they want to capture. They can also specify Prometheus queries that they want to execute during the load and then have them captured through KubeBurner. So to answer your question first on the deleting and recreating, so we have something called churn. So this is what does the deleting and recreating, a thing in the workload. So for example, in this config, there is no churn specified. To keep the demo simple, I haven't included it. But if you include churn config and specify the percentage of churn that you want to do, that basically is the percentage of objects need to be deleted and recreated, and the amount of cycles that you want to do the same thing for. So it has other options like duration, which if you have duration based tests, let's say if you want to say, I want to delete and recreate 10% of the 10% of my workload objects for 1 hour, you can also achieve that using kubeburner. And you can also do the same thing using cycles if you don't want to restrict on a duration basis. And you can also put some delay in between each and every delete and recreate that happens. So does that answer your question about deleting and recreate?
Yes, it does. Yeah. Okay.
So, so that was your first. That was one question, and there was another. Oh yeah, on the examples, is it? Um, oh yeah, on the metrics. So one second. So on the metrics, so here is the example that I was gonna show. So for example, this is our OCP wrapper, which is downstream. But I can show an example here real quick. So along with the config that it takes to kind of orchestrate the workload and have it running, at the end phase, when it tries to talk to Prometheus, it executes a bunch of queries and then captures those metrics. And those queries can also be specified using templating in metrics profile. So it's nothing but a YML file which has the query and the metric alias name. Let's say if you want to capture CPU and memory usage of the node that is running, that has a lot of VMs deployed as a part of workload, and see how your node has been doing in terms of CPU and memory usage, you can specify a query to capture, maybe if it's a worker node, capture CPU and memory usage of all the worker nodes here, either time series or else an aggregated query, and then give it an alias. So kubeburner will capture them in the JSON format and have them ready in this way so that you can look them up in detail. So these can be either published to your local file system as well as to OpenSearch or Elasticsearch to store them persistently, if that's the intent.
So I have one more question. So what we do with our perf and scale stack is we run these jobs 3 times every day, right? So scale up from 0 to 100 VMIs and then plot daily and weekly averages in the graphs that before you presented we were discussing a bunch of graphs, right? Those are daily and weekly averages of let's say VMI creation to running P99 for all the 3 jobs. So it will be 21 jobs per week and averaged over time, right? Um, is there something like that possible when these metrics are dumped to Elasticsearch and Grafana?
So correct me if I'm wrong. So this sounds like post-processing on the runs data that we already have for a month. Is that correct?
That is correct, yes.
Okay, for post-processing, we don't have it as a part of kubeburner, but we have to have some ad hoc scripts to do that. But we don't have it as a part of kubeburner inbuilt. Kubeburner just runs and publishes metrics that are part of that specific run. But there is one option to kind of be able to look back in time in metrics. So kubeburner has this subcommand called index. Let's say if you already ran a workload previously and forgot to capture the metrics, assuming that the Custis Prometheus is still on and running till today, and the workload was run 1 month ago, if you forgot about capturing those metrics, kubeburner can help you scrape those metrics from Prometheus using those metric profiles and then have them published. But apart from that, we don't have any post-processing uh, as a part of kubeburner.
Okay.
So
So
yeah,
the demo. So sorry, Vishnu. So this is cool. Thanks for presenting and going out and showing us this. What would you maybe you can tell us like what would you like to do with this? I mean, I can certainly see some overlap with I mean, essentially what we have now. It's that uses I think we have a little bit of Go code with Kinko and Omega, and then there's another thing that we have is like a script I mean, what would you like to do? Like, what are your plans here with KubeBurner, and I mean, like, what would be the next steps for what you'd like to accomplish?
So what I was thinking is, I mean, just to set the right expectations, I'll be spending more time early next year because I'm gonna be off for the rest of December. But from the conversations that I had with Ali, the existing scripts that were there, they were written in Golang, and they were being used to create the resources, right? Where we don't have that flexibility of having a declarative syntax, which is what is there in the KubeBurner. So I think KubeBurner can add good value over there, wherein we can have everything defined as a template or else YML, and then KubeBurner do the orchestration part. That was one thing that I was thinking to start with, and then go from there with follow-ups and so on. Does it make sense?
Yeah, one thing I would like to add. So we also have our Prometheus instance running right somewhere. I think Lubo can correct me. But once these things are added, the result, if it can be piped to that Prometheus and be persisted and visualized from those dashboards, I think that will be a great uh, iteration on top of the existing charts we have right now.
Yeah. Yeah, from visualization standpoint, we can also bring in some of the learnings that we have. Um, and we some of the tests that we periodically do at Red Hat for some of our customers. But yeah, it's going to be a good collaboration opportunity is what I feel. But I'll get more details from LA. Right now, I just have enough details to justify that Kubernetes can simplify things when it comes to workload orchestration and running the performance tests. But in order to get more refined metrics so that they are presentable, like the visualizations that we were talking about in the early period of this call, we need some optimizations there because the output format that KubeBurner is emitting right now might not closely apply with what Pro is expecting. But yeah, there can be some adjustments done there.
Okay, that sounds good. I think that, I mean, I think certainly what you showed is there's definitely a bunch of things that I can see would be useful and an improvement on the existing solution. So yeah, I mean, I think, yeah, it can doing evaluating and possibly, finding some collaboration and would be great. I think that would be definitely positive for the project.
Yeah, I'll probably follow up with some of you guys, maybe Ale or else Ryan. I mean, once I'm back from holidays, we can start with a collaborative doc, kind of have everything about your stack outlined at one place, and then I can also see what Kubernetes can do and come up with a test plan for one proper workload, and then go from there.
Okay,
Yeah,
that sounds good.
yeah. So yeah, just a heads up. I'll follow up with you guys early next year.
Thanks. Thanks, Vishnu.
Great. Thanks, Vishnu. Okay.
Thanks.
All right, everyone. Thank you very much for your time.